Namaste dear students, I am B.G.Shinde sir and we are discussing chapter number 3 kinetic theory of gases and radiation of 12th standard physics. Today we discuss lecture number 13. It is Kirchoffs law of heat radiation and we see the statement of the Kirchoffs law of heat radiation. We prove the Kirchoffs law of heat radiation by using one thought experiment. So let us start our lecture. And in last lecture we have seen definition of the emissivity. Emissivity denoted by E. And also in one lecture we have seen definition of the emissive power and definition of the coefficient of absorption. Now, according to Kirchoffs law of radiation, the ratio of the emissive power to the coefficient of absorption, the ratio of the emissive power to the coefficient of absorption of a given body is equal to the emissive power of perfectly black body at the same temperature for all the wavelengths, and this is called the Kirchoffs law of radiation. So what is Kirchoffs law? The ratio of the emissive power of the body to the coefficient of absorption is equal to the emissive power of the perfectly black body at that temperature for all the wavelengths, and this is called the Kirchoffs law of radiation, Kirchoffs law of heat radiation. We can also state Kirchoffs law of heat radiation in terms of emissivity, or in terms of this E, which is called the emissivity. We can state this Kirchoffs law in second way. This is the first way. In second way, in terms of emissivity, we can state it as if the body is in thermal equilibrium, and if that body emits the heat radiation as well as it absorbs the heat radiations, then the emissivity is equal to its absorptivity. The emissivity of the body is equal to absorptivity. This is alternative statement, or we can also state Kirchoffs law as E equal to A. It is very simple that emissivity is equal to absorptivity for if the body is in thermal equilibrium and the body is emitting and absorbing thermal radiations, then E is equal to A. This is the alternative statement, or this is also statement of the Kirchoffs law of radiation. Now what this indicates? This indicates that if some body emits less heat, then it absorbs less heat. If some body emits more heat, then it will also absorb more heat. This is the meaning of this Kirchoffs law of radiation. Now let us prove this Kirchoffs law of radiation by using thought experiment. Now for this thought experiment, we imagine the two identical bodies of some identical geometrical shapes. So we consider the two spherical bodies. These are two identical geometrical shapes and same area. We have considered same area. One body A is ordinary body and body B is a perfectly black body. Then these two bodies are kept in the constant temperature enclosure. This is a constant temperature enclosure in which temperature will remain constant for long time, and these two bodies are in thermal equilibrium with the surrounding. This is the surrounding and these are the two bodies, and after long time the temperature of the body A and temperature of body A, B, and also of the surrounding will will be constant, or it will remain same, or it will become same after long time. So these two bodies are in thermal equilibrium. Now when these two bodies are in thermal equilibrium, it means that the amount of heat which is emitted by the bodies will be same as amount of heat which is absorbed by the bodies. And when the two bodies are in thermal equilibrium, the heat emitted by the body is equal to heat absorbed by the body. Now suppose that R is the emissive power. It is emissive power of body A. Suppose that RB is emissive power of body B. Suppose these are the emissive power of body A and body B. Then suppose Q is the quantity of heat which is incident on each body, means on body A and on body B, the total quantity of heat which is incident is suppose Q. Now total quantity of heat which is absorbed by ordinary body A will be A multiplied by Q. This is the total quantity of heat which is absorbed by ordinary body. Means suppose total Q amount of heat is incident on ordinary body A. म्हणजे समजा बॉडी A वर Q एवढी हीट ॲब्सॉर्ब झाली, तर ही जी बॉडी A असेल या बॉडी A ने एकूण जी हीट ॲब्सॉर्ब केलेली असेल, म्हणजे टोटल इन्सिडेंट हीट Q आहे, तर टोटल या बॉडी A ने हीट जेवढी हीट ॲब्सॉर्ब केलेली असेल त्याची किंमत असेल QA equal to A multiplied by Q, where this A is called coefficient of, it is the coefficient of absorption, or it is also called absorptivity. It is also called absorptivity. So the total amount of heat which is absorbed by this body A will be equal to QA, and it is equal to A multiplied by Q. Now total amount of heat which is emitted by this body A is R. So heat emitted by this body A will be capital R, because R is emissive power. Emissive power म्हणजे काय असतं की amount of heat emitted by the body per unit area per unit time at a given temperature, त्याला आपण म्हणतो emissive power. आणि मग याचा अर्थ असा होतो की गिवन बॉडीमधून जेवढी हीट इमिट होईल ती म्हणजे त्याचा तो रॅडियंट, ते म्हणजे त्याचा इमिसिव्ह पॉवर असेल किंवा रॅडियंट पॉवर असेल, आणि म्हणून बॉडीने जेवढी हीट इमिट केलेली असेल त्याची किंमत राहील R. R is the total heat emitted by the body. Then total heat which is absorbed by this body A is QA, and it is equal to amount of heat absorbed A is equal to A multiplied by Q, and therefore we can write R is equal to A multiplied by Q. म्हणजे आपण असं लिहू शकतो की R is equal to AQ. कारण काय? कारण की हीट ॲब्सॉर्ब हा फॉर्म्युला आहे की हीट ॲब्सॉर्ब इज इक्वल टू हीट इमिटेड इज इक्वल टू हीट ॲब्सॉर्ब. मग इथे हीट इमिटेड किती आहे? R आहे. हीट ॲब्सॉर्ब किती आहे? A into QA. आणि म्हणून R is equal to काय असेल? R equal to A multiplied by Q. समजा इक्वेशन 1 असेल, सपोज इक्वेशन 1. Now what about ordinary body? What about perfectly blank body B? For perfectly blank body, the amount of heat which is incident is Q. Q is the total amount of heat which is incident. Then for perfectly black body, all the heat which is incident will get absorbed. म्हणजे perfectly black body साठी काय असतं की जेवढी heat त्याच्यावर incident होईल ती सर्व absorb होईल. And so heat which is absorbed by this perfectly black body will be equal to Q. Q is the total heat which is absorbed by perfectly black body. म्हणजे सर्व हीट जेवढी त्याच्यावर इन्सिडेंट होईल ती सर्व ऍब्सॉर्ब केली जाईल. Then what is the total heat which is emitted by this black body, by this perfectly black body? It is equal to R.B. Now what is R.B.? R.B. is the emissive power of the perfectly black body. And emissive power means what? The amount of heat which is emitted by the body at a given temperature per unit area per unit time. Now here we have considered equal area, and so the total amount of heat which is emitted by the perfectly black body will be R.B. So heat emitted by the perfectly black body is R.B. and at equilibrium we know that heat emitted is equal to heat absorbed. At equilibrium, amount of heat which is emitted will be equal to amount of heat which is absorbed. And so we can write R.B. is equal to Q. This will be equation 2. Now put this value of Q equal to R.B. in this equation 1. So we can write now if we put this value in equation 1, so we can write R equal to A multiplied by R.B. and therefore R upon R.B. will be equal to A. We get this equation, and also you can write R upon A is equal to R.B. and this is the Kirchoffs law of radiation. This is called a Kirchoffs law of heat radiation. What is Kirchoffs law of heat radiation? The ratio of the emissive power to the coefficient of absorption of the body is equal to the emissive power of the perfectly black body at the same temperature at all wavelengths. And this is the proof of this Kirchoffs law. So we have proved this Kirchoffs law. You can also write from this equation R upon R.B. What is R upon R.B.? It is emissivity. Emissivity is ratio of the emissive power of the ordinary body to the emissive power of the perfectly black body. And so R upon R.B. is equal to E. We know this. And if you put this value R upon R.B. equal to E in this equation, put this value in this equation, so E is equal to A, and this is also Kirchoffs law of heat radiation. So this is alternative statement of the Kirchoffs law of heat radiation. So this is a Kirchoffs law of heat radiation. We have proved this Kirchoffs law by using thought experiment. We have drawn one diagram. We have considered two bodies. One is ordinary body, another is perfectly black body B. And finally, we have proved this law. E is equal to A, and this is a Kirchoffs law of heat radiation. So write all these points in your notebook. सर्व हे points notebook वर घ्या, घरी अभ्यास करा. या जो टॉपिक आहे याच्यावर क्वेश्चन असतो की स्टेट द किर्चॉफ्स लॉ ऑफ हीट रेडिएशन अँड ऑल्सो गिव्ह द थेरोटिकल प्रूफ ऑफ दिस किर्चॉफ्स लॉ ऑफ रेडिएशन, असा याचा क्वेश्चन असतो. मी अत्यंत सोपं करून हे सांगितलेलं आहे. आपल्या बुकमध्ये हा डायग्राम नाही आहे, पण हा डायग्राम काढून जर आपण जर अभ्यास केला तर हे एकदम सोपं होतं, एकदम इझी होतं. सो डू स्टडी ॲट होम. घरी अभ्यास करा, घरी नोट्स काढा, प्रत्येकाने आपल्या बुकमधून वाचन करा, आपल्या आपले जे व्हिडिओ लेक्चर्स आहे ते बघा. थँक्यू व्हेरी मच.